In this video, we'll be taking a look at how to utilize Roblox's memory profiler tool to catch and fix memory leaks in your Roblox games. We're going to be doing this live with a game I've worked on to spot and fix memory leaks on the client and the server. Memory leaks can be a total disaster for your games, as steadily increasing memory usage that never gets released can lead to client and server crashes, which leaves a poor user experience for your players. You know, it's also a disaster not hearing about today's sponsor, the WOWCube. It's a new kind of entertainment system. Like a Rubik's Cube had children with a smart gadget, and the WOWCube was born. You twist, shake, and play directly on its 24 screens, like a miniature world you hold directly in your hands. In fact, I've got one with me. And my first impressions is that this gadget has got some weight to it. So not only are you going to be exercising your mind with the interactive apps on the device, you're going to be exercising your forearms as well. And we've got a lot of apps on here that are already installed. In fact, I'm pretty sure most of us know of the game Cut the Rope. And then once we got it selected, we could just double tap. And you can see this is just like the Cut the Rope game on a phone, but this isn't a phone. This is a cube that you can rotate and kind of mess the map around and kind of change the environment. So I want to get that star down there. I got to get this ball to come fall down through the hole. My ball is falling through the hole, but I can't reach that star. I got to actually cut the rope. So I can do that by twisting the cube. And there we go. The rope is now cut. I can go and grab my star. Now this is definitely a unique experience, unlike any gadget I've messed with before. And I can see why people are calling this a cube from the future. Not to mention, you can also create your own games on the WOWCube through their emulator. So if you wanted to take a break from Roblox development to try something new, the WOWCube might just be for you. So if you'd like to have a cool gift ready for the upcoming holiday season, head to the link in the description or pinned comment and join the waitlist. And thanks to WOWCube for sponsoring this video. The most obvious way to determine if you have a memory leak issue on the server side in your game is by looking at the server memory by age statistic under the performance tab, and then you go to the server section. And if you notice that your server memory by age, you'll likely have all of these charts filled out. It'll look something like this maybe. If this is steadily increasing over time, that likely means you have a memory leak in your game. Especially considering that this green area right here represents memory usage being taken up by server scripts. So if we just isolate only the scripts section, you can see over time this is just steadily increasing. It never flatlines, it never goes back down. We probably have a memory leak on the server side. Now, server side memory leaks are more critical than client side memory leaks because servers can exist for much longer than a client's play session in the game. A server may go through hundreds or even thousands of players, and if it keeps eating up memory, your server will eventually crash. So with this confirmation, let's head back into Studio and start profiling. So inside of the game, you kind of want to determine a good starting point for your server profiling. Basically have a default state that you can always come back to and compare when we take memory snapshots. So in the case for this Tycoon game, my default state is going to be when my Tycoon is completely empty and there's nothing in it, and I can do this each time I rebirth in the game. Now to access the memory profiler, we need to open up the developer console by hitting F9, or you can type /console in your keyboard, and that's going to pop up the developer console. We need to go to this top left here and go all the way down to Luau Heap. And this is the Luau Virtual Machine Exploration Tools, yada yada, very fancy name. But basically what we want to do is we want to make sure the category is set to the server, and we want to go ahead and take a snapshot. Now you only want to take snapshots while you're playtesting inside of Studio. You could do this in like a private session, but if you try to do this in a server with a bunch of players playing, you're going to cause a lot of lag in the game. So recommend doing this only in Studio. And we're going to take our first initial snapshot. The game will lag for a second, but then there we go. We got a bunch of information that's going to fill in each of these categories, and we're going to go through each of these categories one by one. So this graph section is going to show each Luau virtual machines registry. So this is going to be this default registry right here. This one just called registry. This is basically all the scripts in your game. This is where they pool their memory. But if you have any other virtual machines in the game, maybe you're maybe you've got other actors in the game, whatever, they'll also pop up in here and it'll say actor, virtual machine, blah, 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 give it a number. But we're going to be most interested in this registry. And when we open up this chart, it's going to lag for a second. There's going to be a whole bunch of information in here. You're going to be like, whoa, what is happening? What is all of this stuff? So basically what we want to pay attention to is going to be these names here. So if we take a look at module at replicated storage, blah, blah, blah. What this is that this is a table being returned by the module script at this path, and it's this size. And for some reason, this one's just huge. It's crazy. I don't know why it's that big, but that's going to be locations for module scripts. You're going to see this array here, which is literally just for arrays in the game. And then we're going to have other locations. So basically, if you see something that says unnamed, and then it gives you a line, and then it gives you a path right here. So unnamed line 86 inside of simplezone.tracker. This is telling you, hey, there is an anonymous function because it's unnamed at line 86 inside of this tracker module, and it's using up this much memory. And then you can of course expand that and see, hey, what is it referencing? Looks like we're referencing some parts, mesh parts unions, and there's a proto down here. If you see proto, I'm pretty sure proto is like, it's like this object that represents a function's code and any of its associated data. You usually don't have to worry about these protos unless you're like creating code during runtime. If you create code during runtime, maybe you clone like module scripts or something, these values might increase. We're going to be basically focusing on all these different functions in here. We have a lot of unnamed or lambda functions, and we want to watch this size increase and particularly look at the ones that are just constantly increasing because those ones likely have a memory leak. And this size is represented in bytes. That's why these values are so huge. But basically, now that we have our initial snapshot, we need to play the game and go through, do whatever, and then come back to this initial state. Before we do that, we can go into some of the other categories. So object tags is just going to tell you how much memory is being used by all of the data types in Luau. So all of the native data types, we got like buffer in here, function, string, table, thread, that kind of stuff. We can go into memory categories. Now this is for, I believe this is usually segregated by script, but you can also specify your own memory categories using the debug library, and any memory categories you set for a thread, they'll show up in here. Now if you have too many memory categories, they're going to be like piled up in here and separated by commas, which isn't that useful, but it allows you to basically see maybe which areas are going to be increasing in size over time as you play your game. If you go to object classes, this is just going to tell you how much memory is going to be used up by certain instances in the game engine. You can see that most of it's being used up by RBX script connections, which could indicate, hey, you're leaking script connections somewhere or signal connections somewhere. Unique references is going to be any references to instances that are not parented in the data model, or basically the whole game. Like when you type game in your script, that's the data model. So all of these are instances that aren't destroyed, but they're parented to nil. Now, if you have a crap ton of these, that could indicate that maybe you have, again, signal connections somewhere that aren't being cleaned up and they're holding on to references to instances that are no longer in the game. You'll see those things pop up in here, and when you expand them, it'll tell you the path of where that particular instance is being referenced from. So if you notice a bunch of instances in here that have a bunch of paths or similar paths, you probably have script connections or signal connections that aren't being cleaned up. And then there's this last category called unparented instances, and it says this view shows engine data model instances that are not parented to any instance, but are also not unique references. For each instance, it will show the set of paths that make it accessible. I have no idea what the difference is between this one and this one, because this is also unparented. These are instances that aren't in the data model, or they have a parent of nil. And this chart's always empty, so I don't know what this one's for, so we're just gonna ignore it. Basically, now that we had our overview of the developer console, or specifically the exploration tools, actually one more thing we need to do is we need to create a snapshot, because when we create a snapshot, you're gonna see a compare button pop up. So when you select your snapshots, you're gonna see the compare button, and then when we click compare, we can compare it to the prior snapshot, and red means memory usage went up, green means memory usage went down, and of course we can explore this, and then if we want to sort it by size, we can click size, and it should sort this for us. It's actually not sorting it. I swore you could sort by size if you click this. Maybe they removed that support. Okay, that's interesting. I remember that you being able to do that before. Okay, whatever, doesn't matter. Red is bad, green is good, and we just need to play the game. And If red continues to go up as we play and we come back to this default state, that's bad. Probably a memory leak. I'll catch you in a few minutes. And now I am back. I did a little bit of testing in the game, playing around, and I have successfully rebirthed after doing a bunch of stuff in the game, and now we're back to this default state that we were when we took our first snapshot. So now we need to open up the developer console again, create a brand new snapshot, and then we need to compare it against the previous, and oh my goodness, we have some memory usage increases. So if we take a look in the registry, we take a peek at what's increasing. Specifically, looks like we've got some increases to this state machine class module. Looks like we've got an increase with this function right here that's observing tag for instances. So looks like we got some up value references. So it could be an indication, because this is coming from an observer, that an observer is not being cleaned up. That could be a possibility here. We have another thing here for zone. This is zone tracking. This could potentially not be cleaning up instances. We have this module proxy, a bunch of values here. So there's a lot of stuff to explore. Specifically, what we would need to do is go to the different of these, go to all of these different functions, take a look at their up value references, specifically take a mental note, or you could take screenshots and take a look at the stuff inside of here that has increases in memory usage, and then start doing a little bit of digging or investigation in your code, because it gives you the location, it tells you the functions. Now we just need to use a little bit of our problem solving abilities to figure out what these memory leaks are. And of course, I'm going to do this again. I'm going to continue playing through the game once more, and then I'm going to rebirth again and take a fourth snapshot, compare it against a third, compare it against the previous ones, just to make sure that we do have some memory leaks going on in the game. Alrighty, I am now back once more to take another snapshot. So let's do it. I'm going to create another snapshot. We're going to compare it against the third snapshot. And what do you notice? We still have memory usage increasing. We do have some decreases in certain functions. So this one actually went down, which is good. This one also went down. So there could be a possibility that it's likely this is not memory leaking. That's specifically an observed tag. Take a look at the previous snapshot and we could do a comparison here. I don't care about that actor one. Specifically, you know, we're going to be more concerned with what is still increasing in memory usage. So the state machine class, definitely there's still a leak going on here. There's likely still a leak happening with this proxy implementation, which is actually quite interesting. So what I'm going to do is I'm going to take a quick screenshot of as much information here that I possibly can of things that are still increasing in memory, and then I'll meet you back inside of these scripts. Alrighty, so one of the memory leaks, or supposed memory leaks, that I saw inside of my snapshot, if I share the screenshot that I got, is that I noticed that there was an increase of memory usage, specifically using the observe attribute observer inside of inventory server setup. You can see there's these increases in memory usage, specifically references to proximity prompts. I decided to go to the inventory server setup, go to line 108 where these unnamed functions were, and what you'll notice is that I've got my observers here, but I forgot to do something. What did I forget to do? I forgot to add these observers into this observer trove. So because of that, these never got cleaned up, which is a memory leak. So I need to add these to my observer trove, and there we go. Now the observer trove, this gets cleaned up all the way down here, but now that we have added these observers to the observer trove, this has been cleaned up and we just fixed that memory leak. It's a simple mistake like that. Another memory leak issue that I found that I took a screenshot of was for my inventory service, specifically for my get items cache unordered function. I do some caching with inventory items for performance reasons, and this function uses a table that stores a bunch of cache information for items. And obviously it's accessing that cache because there's configuration instances inside of there and other information. And this was increasing, constantly increasing, which means it wasn't being cleaned up when those instances were destroyed. So I went to the code that was responsible for tracking items per inventory, and I found that, hey, wait a second, when children are removed, I don't check if that table or the tracked items table becomes empty and remove it from the tracked items per inventory table. because this inventory is acting as a key in the table. I don't clean it up. Now I'm just piling up inventory instances inside of this table and they don't get cleaned. That's a memory leak. So what I should do is all the way down here in this cleanup function, after I go through and say all of those items have been removed because the inventory got destroyed, I need to make sure to copy this, go down here and set that equal to nil. I was not setting that equal to nil, so because of that, stuff was piling up inside of that table, causing a memory leak. So we just fixed another one with the help of the memory profiler. Another memory leak I noticed inside of the profiler was specifically for this third-party zone module. Now, when it comes to third-party modules, that could be a memory leak in the module itself, or it could be a misuse of the module. And in my case, because I saw references to my conveyor setup, I thought, okay, you know what? Let me go check inside of the conveyor system where I'm creating zones if I'm actually cleaning up those zone objects. And surprise, surprise, I forgot to, because you can see that I have my trove here, but I'm not adding my zone to the trove. So when this trove gets cleaned up, I still have a zone object in the game, and that's causing a memory leak. So what I need to do is main trove, add this zone, and there we go. We should, oops, spelt that wrong. There we go. We have fixed another memory leak on the server side. Another memory leak I noticed was coming from my Tycoon class on line 765 from an unnamed or lambda function. Well, at line 765, there is a lambda function right here, and this is leaking memory, and I just realized why. This setup prerequisite function happens when you rebirth or something happens in the Tycoon and there's a prerequisite for the button. It needs to do some setup for that prerequisite. The thing is, a Tycoon can exist as a single object. Every single player in the game joins the game, they have their Tycoon added into the game, and then they can rebirth multiple times in that Tycoon. The issue is that I'm connecting to that prerequisites destroying event through my trove, creating a connection, and then I'm storing that connection object inside of the main trove. This main trove doesn't get cleaned up until the player actually leaves the game or their Tycoon object gets cleaned up, which is obviously not the best thing to do here, because this should technically be happening every single time the player rebirths. So I need to fix that, and I'll fix that here in just a minute. I'll see you in a minute. All right, so I just fixed it by creating a new trove. This trove is specifically for when a new Tycoon model gets created. So this trove gets cleaned every single time a new Tycoon model is created. So that way any prior connections get cleaned up. And then I also fixed that inside. Let me go back to where this connection is right here. So when I go and loop through, when I create a new Tycoon model, there's a bunch of setups in here, and I'm connecting to a triggered event as well, and I'm storing that connection. I was originally storing that connection in the regular trove, but I've also swapped this to the model trove, and then I clean it up here each time a new Tycoon model is created. So boom, we just fixed another memory leak. And now the last major memory leak that I found on the server side was from the state machine class, load directory, line 3, 2, 1. So I decided to go to the state machine class, and it became immediately evident as to why there was a memory leak here, because there is a caching that's happening with the state machine class. This is why you need to be careful of third-party modules, because this state machine class is a third-party module that I heavily modified, but a lot of it has the original code in it. And there is this caching that's happening inside of this cache directory, but guess what? That never ever gets cleaned up. So if you cache something, and maybe because what I'm doing is I'm creating these states, or I'm cloning these states for the AI in the game and putting it in their character models or whatever. And then if those character models get destroyed or whatever, I'm still holding on to references with those destroyed instances, and we're just getting a bunch of destroyed instances piling up inside of this table, causing a memory leak, and that's a no-no. We don't want that to happen. So we need to listen for, I suppose, when the instance gets destroyed and remove it from the cache. All right, so I just decided to get rid of the cache entirely, because I'm not really sure why it was there or what benefit it really had, especially considering the fact that I just copy or I clone my different states and transitions and then put them So basically there's always new instances. The caching wouldn't even work anyways, and it was just causing memory leak, so I got rid of it. And that concludes all of the major memory leaks that I saw on the server. So now what we need to do is play test again, do the exact same process that we did in the beginning, and confirm whether or not our fixes had any impact on memory usage. So I'll see you in a little bit. Alrighty, so I did some more testing. There seems to be a little bit of some more memory consumption going on, but the other issues that we fixed no longer appear to be some of the major contributors to the memory leak, which is good. We fixed those. I took screenshots of a few more areas that there's likely something weird going on, and I'm going to go back in and fix those as well. But this is basically the process of fixing memory leaks in your game using this profiler tool. You can look through here. It gives you a very detailed view of different functions, telling you about the values that it sees, up values, like, hey, this has got script connections here, there might be a memory leak here. You can go and investigate, check your logic, make sure there's no issues there. Just gives you a crap ton of information, and you can fix memory leaks easily using the Luau virtual machine exploration tools, as they call it. So the process for the client is going to be the exact same as the server. You take snapshots, you go through, play your game, come back to a point where you took your original snapshot, and then just kind of rinse and repeat that process, compare against prior snapshots, see where memory usage is increasing constantly and never decreasing, and then you can make safe assumptions that there's memory leaks happening in those areas, take screenshots, do whatever, and then go and investigate your code. And before I end this video, I'd love to give one final honorable mention to the property in the workspace PlayerCharacterDestroyBehavior. Make sure you have that set to enabled. The default behavior, I believe, is actually disabled because they needed to disable it because it impacted a bunch of games negatively. So you do need to do some testing with your game to make sure that having this property enabled doesn't cause any issues. It shouldn't cause any issues because what this property does is that after the player leaves, or the character, like the player gets a new character and the old character gets parented to nil, after like a little bit of time, they get destroyed and cleaned up. So as long as you do everything on player removing, you instantly do what you need to do with the character model or the player model, whatever, and you don't try to access it at a later point in time, you should be fine to enable this property. And a lot of the times you'll have memory leaks on the server side because player instances and character models aren't being destroyed, they're just being parented to nil. So if you enable this, you might notice some fixes to any memory leak issues that you might see inside of that profiler. Otherwise, that's all I've got for you in this video. I hope you enjoyed. Have fun hunting down memory leaks, and I will see you in the next one.